Now let's say we have a more complicated object. So if any of you have ever been to Disney World, you remember that they have a ride that's a bunch of teacups. And so the way these teacups work is each one spins around, rotates on its own. But then not only does each teacup rotate on its own, but they're on some other platform, and this platform is also rotating. Okay, so how would we calculate the angular momentum of something like this, where we have a bunch of objects that are rotating on their own, and they're also rotating around some other center of mass? Okay, so it's simple enough. We say that the angular momentum is equal to the angular momentum of the center of mass plus the sum of the angular momentum rotations. So each one of these rotating about its own axis. We would add that angular momentum as well. Okay, so for the center of mass, right, the angular momentum actually try and be consistent. So angular momentum of the center of mass is going to be, if we would have R1, momentum 1, plus R2, momentum 2, plus R3, momentum 3, plus R4, momentum 4. Okay? And so remember that each one of these is moving with some speed. This whole thing's moving in a circle, so this is moving with some speed, v. But remember that v is just equal to omega r. So the angular momentum of the center of mass is just equal to, so this each p is just m times v. So p sub I is just equal to the mass sub I v sub I, which is equal to mass sub I omega sub I r sub I. So the angular momentum of the center of mass, the magnitude of this is just m omega for, we'll say, a disk in this case, or whatever the teacup is, r1 squared plus r2 squared plus r3 squared plus r4 squared. Okay, and then the rotational component is just the moment of inertia for a cup times the angular momentum of the cup, and then we would have this for each one: the moment of inertia for a cup, angular momentum for a cup, and for the same for the other two components. And so our total angular momentum is just going to be the mass times the rotational speed of the disk, which is this this black platform that they're traveling around, times r1 squared plus r2 squared plus r3 squared plus r4 squared plus 4 times the moment of inertia of a cup, and then times the speed of each cup, right? Omega of a cup because they could potentially all be going at different speeds. Okay, so this would be the total angular momentum. So again, we figured out what the momentum of the main system was, and then we figured out what the angular momentum for each component, for each of the teacups on that is, and then each individual teacup's rotation itself. And so that's about as complicated as these problems can get. After that, things just get to be much much simpler, as we'll start to see as we work some more problems.